Good day everyone, my name is Nathaniel, and these are the remaining videos that will constitute the episode of our mathematics for senior secondary school 1 course. And in these remaining videos we are going to be talking about some important topics too. So in this particular video, in this particular episode, let's talk about variation. Now this is another branch of algebraic processes, and there are 4 different types of variation we'll be covering in this video. Now the first type of variation is direct variation. We have the indirect variation, we have the partial variation, and then we have the joint variation. Now we'll talk about these 4 independently in this video, and just pay attention. I will break them down in complete detail. Now, what's a direct variation? A direct variation is a variation that is the connection between two things, connection between two processes, connection between two happenings, connection between two phenomena that they both increase at the same time. So for example, if there's a direct variation, if there's a direct proportion, or if there's a variation that is directly proportional to something else. For example, if my height is directly proportional to the amount of water I drink, that means as I drink more water, my height increases. So that is example of direct variation. It is represented mathematically as, for example, if h is height, so let's say height is directly proportional, so height will be proportional to water. So that will be, so the amount of water I drink, let's call it A. Now this is how it's represented in mathematics. H proportional to A. This is the symbol for proportionality. Then we have a proportionality constant. So that means H equals that constant multiplied by my variable, which is the amount of water I drink. I say H, the height, my height is directly proportional to the amount of water I drink. So H is equals to Ka. Here K is proportionality constant, or the constant of proportionality. Now that is a direct variation. So an example of direct variation is let me give an example. If 1 pack of sugar costs X naira, what will be the cost of 20 packets? So this is a direct variation, because if you buy 1 pack for X naira, then what will be the cost of 20 packs? So you can just represent it as this. H for atom, when H is what? When H, sorry, this time around we are no longer using height. Let's make use of cost. So the cost of 1 pack of sugar, the number of packs of sugar is n. So let's say n is directly proportional to the cost, n proportional to c, so n is equals to kc. So you can also say that if when n is 1, when the packets of sugars are 1, the cost is x. So that means when x is 1, when n is 1, n equals to k times the cost to be x, kx. That means, well, let's divide both sides by x. So that means k is what? Is 1 over x. So we can successfully say that we can input the value for k in the equation. So that means n equals, substitute the value of 1 over x for k. N equals to 1 over x times dot c. So n equals c over x. So that is one example. Now they asked us, they said, what will be the cost of 20 packets? So what you are going to do, basically, this relationship, you've established a relationship between the number of packets and the cost of each packet. Now what you are going to do, you just cross multiply and change the let's call it the subject of formula. So when we cross multiply, we'll say c equals nx. So that means if c is equal to nx, so this time around the cost is, they asking us to look for the cost of 20 packets. So this time around n is 20, so c will be equal to 20x naira. That's an example of direct proportion. So you can also try some examples on your own. Now let's go to indirect variation or indirect proportion. Indirect variation basically refers to the process whereby as one thing increases, another decreases. For example, if we have a circle, when we divide a circle into 5 sectors, each of the angle of those sectors, assuming that the sectors are equal in angle, each of those angles will be 72 degrees. But if we divide that same circle into 12 sectors, each of those angles in the sector will be 30 degrees. So you see that as the number of sectors increase, the angle subtended by the sector decreases. So if one increase while the other decrease, it's called an inverse proportion or an indirect variation. So it's an inverse proportion. So let's say the number of sectors, let's say the n. So n is inversely proportional. That will be 1 over the angle, 1 over theta. So n is inversely proportional to 1 over theta. Now then, let's say our constant of proportionality should be k. So n equals k times 1 over theta. So n equals what? K over theta. So this will be the relationship between the number of sectors drawn in a circle and the angle subtended by each of those sectors. So this is just an illustration of inverse variation, and let me give an example to illustrate that even further. Now, if x is proportional to 1 over y, so when you sum like this, when you say x is proportional to 1 over y, what they are trying to tell you is that x is inversely proportional to y. So because the reason for that is that 1 over y is the inverse of y, the multiplicative inverse. So if you've studied mathematics for some time, you should understand additive and multiplicative inverses. So that means x is proportional to the inverse of y, or you can just say x is inversely proportional to y. That's an inverse variation. Now then I said, and x is 9 when y is 4. So let's say if x is proportional to 1 over y, then x is equals to k over y. So if we cross multiply, then k will be equals to what? Xy. So that means using any particular values of x and y. So this time around they say x is 9, y is 4. So that means if k is xy, that means k will be 9 times 4. That would be 36. So now this constant will be constant. It will remain for every value. So we can just input it in our equation, and then that will turn to a relationship between x and y. That means x equals, so instead of writing k again, substitute 36 for k. That's x equals 36 all over y. So this is the relationship between x and y. X is equals 36 over y, where k is the constant. Now the asking to also look for the formula that connects x and y. So this is simply the formula that connects x and y. X equals 36 over y. So whenever you change the equation and you look for the constant, you've turned it into a relationship. So I hope you understand that part. So let's move on to the next part of the video. Let's move on to the next part of the. So now let's move on to the third type of proportion, which is joint variation. So this type of variation is when a quantity is dependent on two things at the same time. So you can say that quantity is jointly proportional to the those two quantities. For example, if the color of my skin is dependent on the color of the skin of my parents, and also dependent on my exposure to the sun. So that's a joint variation, because it's the color of my skin is dependent on two things. So it can be two or more things. So whenever a quantity is dependent on more than one thing, it's called a joint variation. For example, let me give you a question. So if they said if when x is proportional to y over z, so let's write that down. X is proportional to y over z. So what does that mean? What this means is that x as a quantity is directly proportional to y. So the value, variable on the numerator is directly proportional to x, or x is directly proportional to the variable on the numerator. Then x is inversely proportional to the variable on the denominator. So let's introduce our constant. So x equals k multiplied y over z. X equals ky over z. Now they are giving us some instantaneous values of these variables. So when y is 7, z is 3, x is 42. So let's substitute into the equation. So but let's make k the subject. Let's cross multiply. By cross multiplication, xz equals ky, dividing both sides by y, xz over y equals k. So that means let's substitute values of x, z, and y. So x is 42. 42 times z is 3 times 3 over y is 7. So equals k. That means 42 times 3 over 7. So that would give us a value of 18. So 18 equals k. So we'll just substitute this value of 18 for k in in our equation and change it to a relationship. So that means x equals, instead of k, we write 18y over z. So this is the new relationship between x, y, and z, and this is also known as a relationship. It's a relationship that connects x, y, and z. So now, next we are asked to look for x when y is 5 and 7. Sorry, when y is 5 and z is 9. So simply just substitute the values of 5 and 9 for y and z respectively. So x will be equal to what? 18 times y is what? 5 over z is 9. So when we simplify that, that will give us that's 10. So x, the value of x will be 10 at this stage. So let's go on to the last example of variation, which is partial variation. Now I like this one very well because it involves constants. In our daily world, a lot of things involve constants, like just the price of your commodities. They involve your constant tax or your variable tax. They involve the constant cost of transportation, involve all those constant costs, and those constant values in your equations, they involve partial variation. Now partial variation is when a thing is dependent on two things and one of those things is fixed while the other is variable. So you can say it is partially dependent on those things. For example, you say it is partially constant and partially variable with that thing. For example, if C is the cost of sewing a cloth, if the cost is C, now and then there's a cost that per cloth, there's a fixed cost per cloth. So that fixed cost, it will be this cost, the cost of the cloth will be proportional to that fixed cost. Let's call the fixed cost A. Then plus it will also be it will also vary as the let's say as the design, as the style or the fashion that the cloth is supposed to be sewn in. So that will be, let's call that fashion. So and then there will be a constant, a second constant multiplying that variable. So let's call it f. So C is proportional to A plus BF. So the variables here are the cost of the cloth, and then the another variable is the fashion or the style of the cloth. So and this cost is partially constant and partially varying as the style. Now let's assuming the let's mess around with this equation. So these equations, they often give simultaneous equations. For example, if the cost is 530 and the okay, if the cost is 530 and the style is okay, let's just put a numerical value for that. So when C is 530 and F is 1600, so let's substitute our value. So C will be equal to what? A plus BF. So now C is 530. 530 equals A. A is the constant plus BF. F is 1600. That's 1600B. This will be our first equation. Then next, it said C is 730 when R is equal to 3600. So 730 equals A plus then 3600 B. That's equation 2. Now you can see that this gives a two equations. 530 is equal to A plus 1600B, equation 1. 730 equals A plus 3600B, equation 2. When you solve these equations, you will get simultaneously by using your elimination or substitution method. You will get C equals or rather A, your constant. So we are looking for the values of the constant now. Our constant A will be equals to 370, and then the constant B will be equals to constant B. Okay, that yes, constant B will be equals to 1 over 10. So you can substitute these values into the equation, and then we'll get C equals the constant A is 370. C equals to 370 plus B and F will be, B is 1 over 10. That's 1 over 10 F. So this is the relationship connecting the cost with the fashion. So this is just an example of various laws and equations that can connect variation statements and relationships. So this is as far as we can go for this video, and hopefully you watch till the end and I will be seeing you in the next episode. Thank you for watching.